Imagine a place no human has ever seen with their own eyes. A realm of eternal silence, hidden from Earth for billions of years. Right now, in this most mysterious place in the solar system, Chinese robots are digging, roving, and discovering secrets that are forcing scientists to completely rethink the history of the moon and even the origins of our own planet. For decades, the far side of the moon was the ultimate frontier, a dark, quiet, untapped treasure chest of knowledge. That all changed in 2019, and what we've learned since then is nothing short of revolutionary. Today, we're going on a deep dive to explore exactly what China found on the far side of the moon, and why it matters for the future of humanity. First, let's talk about why this place is such a big deal. We all know the moon has a near side, the one we see every night, and a far side, often incorrectly called the dark side. It's not dark, it gets just as much sunlight. The real reason it's so mysterious is because of a phenomenon called tidal locking. The moon's rotation is perfectly synchronized with its orbit around Earth, meaning the same side always faces us. We literally cannot see the far side from Earth, but the challenge of exploring it isn't just about visibility, it's about communication. If you land a probe on the far side, the entire bulk of the moon sits between you and Earth. It's a complete radio blackout. It's like trying to have a phone conversation through a mountain. For all of human history, this made exploring the far side a seemingly impossible technical problem, until China solved it. China's solution was brilliant and elegant. In May 2018, 7 months before their historic landing, they launched a relay satellite named Queqiao, which means Magpie Bridge. They positioned this satellite not in orbit around the moon, but at a special gravitational balancing point in space called the Earth-Moon Well 2 Lagrange point. From this stable location, far beyond the moon, Queqiao has a constant, uninterrupted view of both the Earth and the lunar far side. It became the perfect communication bridge. With this problem solved, China's Chang'e 4 mission made its descent. On January 3, 2019, the spacecraft touched down inside the Volcanoes crater, a 180-kilometer-wide impact basin. For the first time in history, a human-made object was on the far side of the moon, and it was sending back data. So why land there? Volcanoes crater isn't just a random hole. It sits inside a massive ancient impact site called the South Pole Ican Basin, one of the largest and oldest craters in the solar system. When the asteroid that created this basin hit the moon billions of years ago, it didn't just leave a dent. It punched through the moon's crust, excavating material from the layer beneath, the lunar mantle. For scientists, this is like having a geological time machine. The Chang'e 4 lander and its rover, U-22, began analyzing the soil and rocks. Almost immediately, they detected minerals like olivine and low-calcium pyroxene. These are not common crust rocks. These are mantle materials. The composition of the mantle tells us how the moon formed. The leading theory, the giant impact hypothesis, suggests that a Mars-sized object slammed into a young Earth, and the debris from that collision coalesced to form the moon. Rocks from the moon's mantle are like a fossil, holding the chemical fingerprints of that cataclysmic birth, an event that was also a critical part of Earth's own origin story. But that was just the beginning. The real shock came later. The prevailing theory was that the moon's far side cooled and solidified much faster than the near side. Why? Because the early Earth was still a volcanic, molten ball of rock, radiating intense heat toward the near side. The far side, facing away, should have frozen solid first. Scientists expected to find only ancient, billions of years old volcanic rock on the far side, and they did find ancient rock. In 2024, the Chang'e 6 mission successfully returned samples from the far side, including a fragment of lava dated at a staggering 4.2 billion years old, the oldest moon rock ever discovered. But here's the twist. They also found a lot of relatively young volcanic rocks. The average age of the volcanic material in the Chang'e 6 samples was around 2.8 billion years old. The side that was supposed to cool down first stayed hot and molten for much longer. This completely upends our models of lunar geology. It suggests the moon was geologically active far more recently and for a longer period than we ever imagined, and scientists are now scrambling to figure out why. While Chang'e 6 was busy on the far side, another mission, Chang'e 5, was making a discovery on the near side that has massive implications for our future in space. In 2020, Chang'e 5 landed in a region of ancient volcanoes and returned samples to Earth. Among those samples, scientists found a new, transparent, colorless mineral. They named it Changesite. Why? It was the sixth new mineral ever discovered on the moon. But here's why this little crystal is so incredibly important. It contains a trapped isotope called helium-3. Helium-3 is a resource we desperately want. For billions of years, the solar wind has been depositing it onto the lunar surface. We don't get it on Earth because our magnetic field protects us, which is great for life, but it means we miss out on this resource. Why do we want it? Because helium-3 is the perfect fuel for a potential future technology, nuclear fusion. Just 40 grams of helium-3 could produce the same amount of energy as 5,000 tons of coal, but with virtually no radioactive waste. There are an estimated 1 million tons of it on the moon. If we can master fusion, the moon becomes a gas station for the entire planet. And that's not all. Chang'e 5 also found actual water molecules bonded within another new mineral. This shows that water might be more widespread than we thought, not just locked in the deep, dark craters at the poles. This is critical because water means life support and rocket fuel. It means future lunar bases aren't limited to just 1 or 2 locations. Think about this. It's as if an alien landed on Earth, walked around a single theme park, and then pretended to know everything about our planet. That is what we've been doing with the moon for 50 years, making huge assumptions based on a tiny fraction of the surface. China's Chang'e missions are systematically dismantling those assumptions. They are proving that the moon has a long, complex, and violent history. They are finding the resources, water and helium-3, that could fuel humanity's expansion into the solar system. As the world looks toward the future, with NASA's Artemis missions aiming to return humans to the moon and China planning its own international lunar research station, one thing is clear: the moon is not just a destination. It's a key to understanding our past and a gateway to our future. The far side is no longer a place of mystery. It is a place of discovery. What do you think? Will this new wave of lunar exploration be a global collaboration, or will it become a new kind of space race? Let me know your thoughts in the comments below. Thanks for watching the deep dive.